Okay, this is a video on polynomial inequalities. So just to go over these inequalities signs. So you need to know these or you're gonna have a lot of trouble. So this expression right here means f of x is greater than 0. So that's what this sign means. The next one is saying f of x is less than or equal to 0. And if someone wrote it the other way around, it's a little bit weirder, but this would be saying that 0 is less than f of x, which is kind of weird to say. So I would prefer to say it like f of x is actually greater than 0. So just be comfortable with those signs. And if you're not, picture a stack of books. If that stack of books is totally equal, like 3 books in each stack, that's where the equal sign comes from. So like totally equal. Whereas if this stack of book is actually greater than the other stack, that's where that comes from. So you know, like this stack of books is greater than this stack of books. So that's kind of how that sign goes. So this would be the greater than sign. So this would be like f of x is greater than 0. So picture f of x is this big tall stack of books and 0 is a really small stack of books. And then this is your less than sign. So this is like f of x is less than 0. So it's smaller. So you can kind of picture inequality signs like that. Okay, so let's try it with a quadratic. So I've graphed it and I've shown it in factored form too. So if I have an inequality like this and I want to solve it, I can use my graph. So this is saying, when is my parabola less than 0? And it's always talking about the y value. So when the y value is less than 0, that's all the values under the x-axis, right? Because y is equal to 0 here, and then it's like -1, -2, -3. So for our graph, we care about all of these values down here. So if we wanted to state when this parabola is less than 0, we would simply say, according to its x values, when it's between -1 and 3. But we don't want it to include -1 and 3. So we would just say, when x is greater than -1 and less than 3. That would be our answer to that question. Now if we wanted to say, when is our parabola greater than 0, now we look at all the values above y equals 0. So all of these top ones. So if we wanted to answer that question, we would say when x is less than -1 and when x is greater than 3. Right? So here's where x is 3. So anytime it's greater than 3, and anytime x is less than -1. So those would be our 2 answers for if it asked us if it was greater than 0. And then the other way you could solve this, actually no, I'm just gonna stick with graphs for this video. Okay, let's try a polynomial. So let's say for this polynomial, we wanna know when the polynomial is greater than 0. So if I look at my graph, when is it above the x-axis? So it's greater than 0 in this little section and in this big section here. So I can describe that using the roots. So I can say when it's in between -4 and -1. So when x is greater than -4 but less than -1, and when x is greater than 2. That would fulfill those highlighted parts of the graph. So when x is greater than -4 or less than -1. That would describe this section here. And then when x is greater than 2, it would be here. Okay, let's say we don't have a graph yet, but it is in factored form. We could quickly graph it. So I know I have a root at 0, I have a root at 1, and I have a root at -2. So I have 3 x-intercepts, and I know this one is order 2, so like a double root. I also know this is a even degree function, because it's a degree 4, 2, 3, 4. And I know it has a positive leading coefficient, so it's going to end up going from Q2 to Q1. So if I had to graph it, it's going to look something like this-ish. So if I wanted to state when is my graph less than or equal to 0, in all of these parts down here, and actually basically from the root that is -2 all the way to +1, it's going to be less than or equal to 0, because even here at 0 it's equal to 0, so that is fine. So I'm going to say anytime my graph is between -2 and 1, my polynomial will be less than or equal to 0. And I'm including -2 and 1, that's why I have the or equal to signs, because I want to include them too, because it can be equal to 0 also. So that would be the answer to that one. And that is it. So that's how you use a graph to decide or to solve inequalities. So I'm guessing most people need to work on their sign practice.